Back Physical Science 20. So this is the last part of the 1.4. So we looked at light year. We looked at the finite speed of light, 3.00 times 10 to the 8 meters per second. Some of the earlier ways of measuring it. So we'll look at this now. Light from the sun takes 8 minutes to reach the Earth. About how far is the sun in terms of meters and then kilometers? So first of all, we have to have time in terms of seconds. So 8 minutes, 1 minute is 60 seconds. So that works out to be 480 seconds. And we're looking for D, and the speed of light, of course, is 3.00 times 10 to the 8 meters per second. So V equals D over T. And the speed of light and the time it takes light from the sun to reach us, 480 seconds. Isn't that amazing? 480 seconds light from the sun exits the sun. It takes that long to reach us. So 3.0 times 10 to the 8 multiplied by 480. And that gives us 1.4 times 10 to the 11 meter sticks. That's a lot of meter sticks. And of course, converting meters to 1,000, we just simply divide it by 1,000. 1.4 times 10 to the 8 kilometers. All right, let's look at the last question. How many years would it take light from Earth to reach Uranus? Use the distance when Earth and Uranus are at their closest proximity, 2.6 times 10 to the 12. So first of all, we're going to figure out how many seconds there are, then convert it into the remaining part here. Minutes, hours, days, and then years, if it makes sense. Try to get a grasp of how long it takes. So the distance is 2.6 times 10 to the 12 meter sticks. V, of course, is 3.0 times 10 to the 8. Oops. That's 10 to the 8 meters per second. And we are looking for T. So V equals D over T. So 3.0 times 10 to the 8. 2.6 times 10 to the 12. 10 to the 12. Ooh, that's messy. There we go. 10 to the 12 over T. And of course, rearranging this equation to solve for T, this is how we do it. So 10 to the 8. So that's going to give us a number in seconds, 8,666.6 seconds. Oops, I should have moved my video up here. So yes, so solving for an unknown in the denominator, simply interchange here as the shortcut. 8,000 seconds. Now, how big is that? 8,666.6 seconds. 60 seconds is 1 minute, but we'll go one more step because I think we'll have to deal with it in terms of hours. 60 minutes is 1 hour. And I think what we get there, let's see, I think we get something like 2.4 hours. So if you look at your calculator there, 8,666.6 divided by 60 once, then divided by 60 again. Yeah, so 2.4 hours. And we'll stop there because that makes sense. We know how long 2.4 hours is. So isn't that interesting? Send a signal from Earth and it gets to Uranus in 2.4 hours. That's amazing. It takes that long for light to reach there. Now, light, of course, is really fast, 3.0 times 10 to the 8. So if you're to go in a spaceship that traveled that fast, which of course isn't possible yet, it would take 2.4, it'd be a 2.4 hour trip to get to Uranus, if we could in fact go that quick. So it gives you an idea of how quick that is, and yet it also gives you a respect for the distance between planets. That's a really big distance because it takes that long for a light flash to get there. All right, you should be able to do the assignment now, and we'll see you again.